Ultimately, our goal must be to make our technology accessible, user-friendly, and ready for real-world applications. So Lucy can, for example, already help in AI-related tasks. It comes to mind image recognition of pattern detection. The idea wouldn't be to use the quantum unit processor by itself, but to combine it with classical existing methods. For example, so the idea would be to process data through the quantum processing unit and then to extrapolate the final prediction through classical models. So as a matter of fact, Lucy will be mainly used to obtain a proof of concept of applications, and so to show that we can have a real value in real-world use cases. So Lucy can be used nowadays, especially in all kind of hybrid architecture algorithm, which is for sure what is most promising nowadays for quantum technologies. So the idea would be, once again, to exploit the quantum processing unit to do what is best for it, which basically is data processing, in order to enrich already existing classical protocols. What comes to mind first is, for example, quantum reservoir computing, that is quite trendy nowadays. So the idea would be, once again, to enrich the processing of the data without having to deal with the complex part of the training of the task. And this is pretty suitable for nowadays technologies. So ultimately, our goal must be to make our technology accessible, user-friendly, and ready for real-world applications. In order to do that, we have to guarantee that people can use our technology and can access it in a friendly way. We developed a library that is called Merlin that helps even not non-quantum experts, just AI experts, to use quantum protocols within their already existing classical workflow. Lucy is a transitional point. We go from quantum experiments to real-world usage. What we bring together in this operational framework is both the hardware, the software, and the users, which is essential to unlock a European quantum ecosystem.